Okay, so we've got our data in desmos. Remember, x values are time values, y values are distance values. We've got our axes labeled. X is the time axis, y is the distance axis. We've got our data points visible. They are using most of the screen that we have available. Everything looks great. We want to get desmos this time to find the line for us. Now remember, Um, at time zero, the ball had traveled zero distance. That seems intuitive. So we want to have, I've added this 0, 0 point. You can add it to if you want to, you don't need to. Um, and we want our line to go through the origin, through that 0, 0 point, because at time zero, it should show distance of 0. So we're going to leave out if you think about our original linear equation, y equals mx plus b, we're going to leave out the b term entirely. We're just going to have y equals mx, and it's going to find m for us. But we can't just type y equals mx. That does something different, gives us a slider. This time, look up here at our data table. Notice that it's y1 and x1. So we need to refer specifically to y1. So we're going to type y1. It automatically knows that I'm trying to find this. So it's made that one a little subscript there. Now, y1 equals, but we're not going to type in equals either. We're going to use what we call a tilde, the shift of the key that's up in the upper left next to the number 1 key. You're going to hold down the shift button right next to the number 1. There's this button. It's got two little punctuation marks. Top one, it's called a tilde. Type it. Look at that funky little thing. Now, y equals mx. We're just going to type m, but, and then x, but we're not going to type just x. We're going to type x1. And bam, look at that. It's finding a value for m. If you look below what we just typed, it's got statistics that r squared equals 0.99993, too many nines, sorry, 0.993, too few nines. Anyway, because if that's close to 1, that means that we've done a pretty good job of fitting our data here. And then it's giving us a value for m. M equals 82.2. Now, if you've done this any other way, you will probably have found a value of 82 if you use my data. You're not supposed to use my data. Remember, you're using your own data. This one's finding an even more exact value than 82, 82.2. So our slope is 82.2 in actuality. So when you go to copy this into your lab report, you would copy y equals 82.2x. That's the actual equation that you should be using to refer to in your lab report.